Okay, looks like we're live. Good evening, everybody. Welcome to a slightly breezy but nice evening in the Death Valley region of Eastern California. I'm Mike Jerry, and we've got some galaxies to look at tonight. So, we're going to get to that here. Okay, let me turn off that so we can see this. And yeah, we've got a batch of galaxies to look at. First, though, I'm going to need to get things resized so you can see what I'm looking at here. Okay, let's bring that down and get the window size correctly. Probably something like that. Alright, let's find a galaxy here to look at. First I want to pick up the size a little bit so we're seeing a little bit bigger. This will limit the size to the bigger kind of stuff that we want to look at. So let's go ahead and do that. In fact, we're already on Alcade, so let's do M101 to start. Let's start off big. What the heck? As you can hear, got a little bit of a breeze tonight, but hopefully it won't be anything more than an intermittent little breeze. It's not supposed to be anyway. Guess we'll see. Okay. Right, let's on that. Okay, now let's resize you a little bit. So, oh, come on. No, that's not what I was trying to do. I need you to go up there. And you're not cooperating. Okay. Something like that'll work. So M101, or the firework, the pinwheel galaxy. There's our first sub. Looking very blue. Guess we're going to need to balance those colors a little bit. Okay. And we can take a look-see here what Wikipedia has to say about that. This is M101. Oh, right. I need to type out Messier for this. Alright. The Pinwheel Galaxy is a face-on spiral galaxy located 21 million light-years away, so not real far away. One of our closer neighbors, actually. It was discovered by Pierre Marchand in 1781 and was communicated that year to Charles Messier, who verified its position for including in his catalog as one of its final entries. discovered the galaxy and described it as a nebula without star, very obscure and pretty large, 6 to 7 arc minutes in diameter, between the left hand of Bortle and the tail of the Great Bear, Ursa Major. It's difficult to distinguish when one lits the grating wires. Anyway, 21 million light years away. It's got a very distinct arm that kind of just sticks off. One of them sort of sticks off further than the others, so kind of a distinct looking galaxy. But one of the closer, brighter ones to us, so definitely a fun one to look at if you get out with a telescope. It's definitely a nice telescope object. Even binoculars can see it fairly well. Breeze keeps up, I may end up keeping my mic muted when I'm not talking, because I know that's a constant noise, but hopefully the breeze won't do too much stuff. Won't get too big. Let's see what else does Wikipedia have to say. Wilhelm Herschel wrote in 1784 that the galaxy is one of several which in my 7, 10, and 20-foot focal length reflectors showed a modeled kind of nebulosity which I shall call resolvable, so that I expect my present telescope will perhaps render the stars visible of which I suppose them to be composed. Yeah, he thought that he'd be able to resolve individual stars. He had no idea how far away it was. We cannot resolve individual stars in any other galaxies, even with our biggest telescopes, because they're just too darn far away. It says that though the galaxy can be detected with binoculars or a small telescope, to observe the spiral structure without a camera requires a fairly large instrument, very dark skies, and a low power eyepiece. It's a large galaxy, a diameter of 170,000 light years. By comparison, the Milky Way has a diameter of 87,000 light years. I've actually heard the number much bigger than that, but anyway, M101 has around 1 trillion stars, which also is much larger than ours, about double the size. It has a disk mass on the order of 100 billion solar masses, along with small central bulge. This characteristic can be compared to those of the Andromeda Galaxy. The population of hydrogen beta regions. Let's stretch this a little more. Oh, I know I haven't got those going yet. Definitely a pretty one, though. Most of what we'll be seeing tonight will be a lot smaller than this, but I just figured this is a good way to start. And we got us a nice satellite photobombing right through there. Actually, that might even be a plane, given how the light gets brighter and then dimmer and then brighter and then dimmer. That might have been a plane going through there with blinking lights as it went through the exposure. Alright. That is M101. A pretty galaxy. So now we're going to go do M51, the Whirlpool Galaxy, which is another pretty nice bright one. This is actually an interacting pair of galaxies. Let's center that up with a quick plate solve. And we will get started on it. Actually, while this is doing this, I can do something else I should have done, which is give you a quick look at what it is I'm using to do this stuff tonight. And so my telescope is a 6-inch imaging Newtonian telescope, focal ratio of 4. It rides on top of an AM5 harmonic mount, and camera gets stuck in up here. Tonight is 183 color, which is kind of the camera I've pretty much settled on. I've sold all of my other cameras because this one just works really well for this particular focal length. And yeah, I'm sitting behind this laptop here out of my cement pad and bringing you these images. So just a simple reflector telescope that has a camera stuck in it. And that's what's bringing you the images tonight. Here is the Whirlpool. So, 2 interacting galaxies. They're together there. And this is Messier 51. The Whirlpool Galaxy. It's an interacting grand design spiral with a Seyfert-2 active galactic nucleus. It lies in the constellation Canis Venatici, and it was the first galaxy to be classified as a spiral galaxy. It's about 23.5 million light years away, so not a lot further than the Pinwheel Galaxy that we just looked at is. And it's also pretty close, which is why it's pretty bright. And it's about 80,000 light years in diameter, so it's about half the size of M101 that we just looked at. And it's 2 interacting galaxies that are right together. Galaxy and its companion, NGC 5195, are easily observed by amateur astronomers, and the 2 galaxies may be seen with binoculars. The Whirlpool Galaxy has been extensively observed by professional astronomers who want to understand galaxy structure and galaxy interaction. Its pair with NGC 5195 is among the most famous and relatively close interacting systems, and thus is a favorable subject of galaxy interaction models. It was discovered in 1773 by Charles Messier himself while hunting for objects that could confuse comet hunters, and was designated as M51. William Parsons, the third Earl of Rosse, employed a 72-inch reflecting telescope in Ireland and found the whirlpool to possess a spiral structure, the first quote-unquote nebula to be known to have one. These spiral nebulae were not recognized in galaxies until Edwin Hubble was able to observe Cepheid variables in some of these spiral nebulae, which provided evidence that they were so far away that they must be entirely separate galaxies. So when they first started discovering these things, they called them nebulae because they thought that's what they were. They didn't realize they were massive collections of stars. They thought they were clouds of gas and dust like the nebulae that are in our own galaxy. With the advent of radio astronomy and subsequent radio images of M51, unequivocally demonstrated that the whirlpool and its companion are indeed interacting. Sometimes the designation M51 is used to refer to the pair, in which case the individual galaxies may be referred to as M51A and B. It's really quite a pretty pair of galaxies, not only because they are interacting and kind of spreading out their stars all over the place, but the difference in color too is very nice, with the whirlpool itself being more bluish and the smaller interacting galaxy being a more yellowish, almost tan color. It gives them a nice contrast. And another nice satellite blasting through. At least it stayed away from the objects mostly. That's M51. So we started off with a couple of pretty big bright ones. So now we're going to do probably step down to some smaller stuff here. Much more distant galaxies. These two here were pretty local, pretty close by. But this one will be a pretty nice one too. This will be M63, the Sunflower Galaxy. Another Messier object here. You can see it right down there. So far, these first three we've started off with have all been Messier galaxies. And of course, I'm cherry picking all the possible galaxies there are. There are zillions of them. You can see the little red circles here are all the galaxies. And as I think I showed you last time, I've got these filtered, all the galaxies filtered down to only show the biggest and the brightest ones, so that we have those to choose from. But you can see there's still quite a few in here, but if I turn off that filter and try to show all of them, the whole screen just turns red. So, because there are just so many galaxies out there, there's billions and hundreds of billions. We just, every time we think we have a handle on how many galaxies we think there are out there, we get more information. In this case, James Webb going out and getting images that are far deeper than the Hubble telescope was able to get, and it just finds 10 times more galaxies than the Hubble was able to find. So the deeper we go, the more we find, and it's just crazy how many galaxies are out there. Just seemingly endless numbers. That settle in there. So this one is going to be M63, the Sunflower Galaxy. Another one of Charles Messier's catalog entries. Let's see what we can find here. M63, also called the Sunflower Galaxy, and you can tell because it's there's a little bit of there's texture around the edges, and as we get more subs in, we'll be able to look a bit more closely. Right now it's still pretty grainy, but as it comes in, we'll be able to see more closely. It's a spiral galaxy in Canis Venatici with approximately 400 billion stars. M63 was first discovered by Pierre Marchand and then later verified by Charles Messier on June 17 of 79. The galaxy became listed as Object 63 in the Messier catalog in the mid-19th century. Anglo-Irish astronomer Lord Rosse identified spiral structures within the galaxy, making this one of the first galaxies in which such structure was identified. So this is classified as a spiral form with no central bar feature and moderate to loosely wound arms. So as we get more sub-exposures in here, we'll be able to see more of the spiral nature of this outer area. Doug, thanks for stopping in. Hey, good to see you. Haven't seen you in a while. Actually, I haven't seen one of your broadcasts in a while. So, it's good to see you. Thanks for coming in. Yeah, that's one bad thing about summer is we have to start so late that out here on the West Coast. This means it's way late for you guys by the time we can get started out here. So I really appreciate you being here, just to stop in and say hi. So. In fact, I haven't seen one of your broadcasts in so long, I don't even know which catalogs you're working. I don't know what, I think you was doing Herschel, you were doing Caldwell for a while, and gosh, I lost track of whatever you're working on recently. Just haven't seen you out in a while. Oh, Kat says, thanks for sharing your knowledge and images. Well, Kat, thank you for being here. If it wasn't for you showing up, I wouldn't be doing this. Well, actually, that's not true. I still love doing astronomy, but being able to reach out to folks wherever they are and share this amazing stuff that's out there is just a real treat. So I'm glad you're enjoying it. You finished with Herschel, okay. So what are you? Is that you just finished with it? Is that what are you now moving on to something else, or? Let's see, what else to say here? There is a general lack of large-scale continuous spiral structure in the visible light, so it's considered a flocculent galaxy. However, when observed in near-infrared, a symmetric two-arm structure is seen. Each arm wraps 150 degrees around the galaxy and extends out to 13,000 light-years from the nucleus. It's a weakly active galaxy. Displays an unresolved source at the galactic nucleus that is cloaked in a diffuse emission. So this one is almost 30 million light years away. So this one is a little bit further away than the ones we've seen. We keep working our way a little bit further out. We started with the pinwheel, it was 21, and then went to the whirlpool, which was 53. I'm sorry, 23 or 24 or 5. And this one is pretty much 30. Oh, 1001 celestial wonders. Cool. Okay. Well, I look forward to being on and catching one of your broadcasts next. As I said, I haven't caught one in a while, so I'm assuming I'm still on your email list. Because unfortunately, even though I have subscribed to your channel, and I subscribe to a number of other folks' channels on YouTube, I never get any email notifications of folks I've subscribed to's videos or broadcasts. I never get notices of them. I'm not sure why that is, but I don't. And I've tried double and triple and checking settings, and so even when you set up a broadcast, I don't, none of the folks who I am subscribed to do I get notifications about that. So I kind of depend on your emails to alert me that you're having one. I assume I'm still on your list, but I just haven't seen one in a while, so maybe you just haven't done one in a while. But yeah, I will definitely check one out here soon when you do one next. Summer's coming, so hopefully you'll have some good air. Winter is always the best air, but summertime has got nice temperatures, so although we do have to start late. Yeah, endless clouds. Yeah, that's when you're in that part of the world, the right coast. It's a very green country where you are, but the price for that is clouds and moisture. Well, I look forward to seeing your next broadcast, so hopefully I'll get to say hi. Well, this is starting to go. We're starting to even pick up a little bit of structure here, a bit of a dark lane here, but now you start to see a little bit of the spirals coming out and around here. So you're seeing a bit of the spiral structure. No real clear arms, but definitely some spiral swirling structure here and a core. Yeah, Kat, I have checked notifications, email notifications, the preferences. I subscribe and ring the bell, and just none of it seems to make any difference. I've even had some other YouTuber friends kind of look at my settings with me, and nobody can seem to figure out why I'm not getting notifications about broadcasts. I get other notifications, like when somebody subscribes to my channel, or when I get a comment on one of my videos, after it becomes a video, after the broadcast is done. I get all of those notifications with no problem at all. But for some reason, so YouTube is sending me emails, but for some reason, notifications about broadcasts for those who I am subscribed to just don't seem to happen, which is kind of odd. Good night, Doug. Thanks for stopping in. Great to see you. And look forward to checking out your next broadcast, if your clouds ever part. We've had a fairly cloudy winter here too, but got a little stretch here of a couple nights that are just really nice, so it was good to get out and get it done tonight. I haven't been doing as many broadcasts this last year as I've done in the past, so good to get out and start getting those together again. I've been mostly just broadcasting on Night Skies Network, and which is a great group, and it's a good place to broadcast, because you actually can do live chat. I'm not the only one whose voices can be heard. You can actually, if you have a microphone, you can actually chat live with everyone else on the broadcast, which is a really cool thing. So, and it's a lot less restrictive than YouTube, etc., no advertising, etc. So, it's a great place to go. In fact, you should check it out, nightskiesnetwork.com, and there's broadcasts going most every night from both coasts. So early evening, the earlier East Coast and the West Coast. If I have the app on my phone. No. Well, yes. I'm pretty sure I do have the YouTube app. I can set on the phone to get app notifications. Well, I've never looked into that. That's probably a good idea. I have never looked into using the app to set notifications for that kind of thing. I'd prefer to get them in email. I'd rather not have my phone chiming for that kind of thing. I prefer to keep that sort of thing to a minimum if I can, but it may be better than nothing at all, so I may end up doing that. But thanks for the suggestion, Kat. I may just look at that. It's nightskiesnetwork.com. And it's based on an educational software actually called Big Blue Button. And so when you go to the website, you can actually see if anybody's broadcasting, you'll see there'll be a pulsing blue button for anyone who's broadcasting. Sometimes there's more than one person broadcasting on any given evening. I haven't actually looked over there tonight, but in fact, I could just go look real quick to see if anybody's there. Yeah, so there's a couple of people. Well, yeah, NorCal Skies, who's David, he's broadcasting tonight, and looks like somebody, I think Dave Martin was, or somebody was broadcasting as well, and they didn't close their broadcast down. But yeah, you can see there's a couple of blue buttons there, and it's great. You can just click into one of those, and then you can choose whether you want to just listen, or you can actually speak and listen if you have a microphone, or you can just X out of that, and you don't have to have any sound at all. You can just watch. So it's a pretty cool place to see this kind of thing going on almost every night. Usually someone in the country has clear skies. Usually one coast or the other has clear skies, and there's even a few folks in the middle. Texas, Oklahoma, etc., who will sometimes broadcast as well if they've got decent skies. So usually somebody somewhere has a half-decent night and is broadcasting on Night Skies Network. That's where I like going. When I show up there, I show up as Tacopa Skies. Anyway, there is M63. So, the Sunflower Galaxy. So called because of its outer texture, looks a bit sunflower-like. So, let's see where we're going to go next. Okay, what do we got here? Here's another one. Let's see what this one is. NGC 5023. Well, this one will be a much smaller one. This one will be a smaller guy. So we'll see. But that's kind of the par for the course here. Is most galaxies are pretty darn small because they're so far away. They're massive objects, but they're really, really far away. What we got here? 4182. Yeah, we'll go to this one next. Seems a good size. But we'll see what this little guy looks like. Yeah, it's just kind of a little sliver. A little sliver in the sky here. So this will be a spiral that's mostly we see edge on. And in fact, there's another one right there. This is one of those views where we have multiple galaxies in the view at one time. But that's why they call this galaxy season. It's a section of the sky that's really, really rich with galaxies. Okay. What did I say this was? NGC 5023. Okay, put that up here. NGC 5023. Let's see if we can get any info on this guy. Say 5023. Yes. It's an edge-on spiral located against Canis Venatici. It's considered a member of the M51 group. It's approximately 50,000 light years across. Yeah. Well, they don't say how. They say how big it is, but they don't seem to say how far away it is. It looks actually fairly even the Hubble picture looks fairly undistinct. So I think we're going to just move on from this one. This one's not a real interesting one. So let's try IC 4182. This one looks like a bit bigger. Hopefully a bit more interesting. Okay. Alright, first sub coming in. Oh, the satellite going through. Oh, wow. Well, that's interesting. Huh. That is a pretty faint, nebulous thing. It's very faint. It's very faint. We'll try taking waiting through a couple of subs here, but it's a really faint one. It's a real faint one. Let's see what the annotation says about this. Huh, it actually doesn't have an NGC number. Interesting. IC 4182. Yeah, I'm not sure we're going to get much out of this either. IC 4182. 4182. Nope. Nope, nothing. This is the kind of thing that would take, you know, if we sat on this for half an hour, 45 minutes, or even an hour, we might be able to pull out some detail in something this faint, but it would take much longer, and I would need much longer than 1 minute exposures this would need 3, maybe even 5 or more minute-long exposures to really pick out anything that's in here. So I think we'll move on from this one. It's for the purposes of what we're doing tonight, it's a little bit too dim. So we will go to M94, the Croc's Eye. Center that up and get us started. This one should be a lot easier to see. Alright, let's see what you have to say about this one. Monsieur 94. Go. The Crocodile Eye or Croc's Eye Galaxy. It's a spiral galaxy. It is discovered by Pierre Marchand in 1781. Catalogued by Charles Messier 2 days later. Although some references describe M94 as a barred spiral, the bar structure appears to be more oval-shaped. The galaxy actually has 2 ring structures. It's classified as having a low ionization nuclear emission region, or LINER, nucleus. Yeah, so we can already see the 2 ring structures. Number 1, the inner, brighter one, and number 2, the faint, fuzzy outer one there. And as we get more sub-exposures, and we'll be able to pick up more detail, some of the texture in, hopefully, both of these things. We'll see. It has an inner ring with a diameter of 70 arcseconds. These rings appear to form at resonance points in the disk of the galaxy. The inner ring is the site of strong star formation activity and is sometimes referred to as a starburst ring. The star formation is fueled by gas driven dynamically into the ring by the inner oval-shaped bar-like structure. A 2009 study showed that the outer ring is not a closed actual ring, but a complex structure of spiral arms. When viewed in infrared and ultraviolet. The outer disk contains about 23% of the galaxy's stellar mass and contributes about 10% of its new stars. In fact, the star formation rate of the outer part, the outer disk, is approximately 2 times greater than the inner disk because it's more efficient per unit stellar mass. There are several possible external events that could have led to the origin of M94's outer disk, including the accretion of satellite galaxy or the gravitational interaction with a nearby star system. However, further research found problems with each of these scenarios. Therefore, the report concludes that the inner disk is an oval distortion, which led to the creation of this galaxy's peripheral disk. The inner disk of M94 is an oval distortion, which led to the creation of this galaxy's peripheral disk. I'm not really sure what that means, but anyway. Oh, hey, thanks, Larry. Appreciate you being here. Yeah, I know it's late. We don't get to start very early these days. When that's the summer light shows up, we don't get to get started very early. So thanks for coming by. I know how difficult it is for you East Coasters to catch any of my stuff live. Gotta stretch it a little more here, get a little more of that outer ring. If I stretch it too much, it starts looking pretty grainy, but it's really the best way to catch the outer ring is to stretch it really good, and then hope subsequent stacks can smooth it out a little bit. You really can't see the inner versus outer part. You're getting that outer cloud, that outer haze is actually the outer ring system of this galaxy. So looks a little grainy at the moment, but some more sub-exposures should help smooth things out. While it's doing that, I think I want to go fill my water up, so I'll let you guys enjoy this. I'll be back in a couple minutes. What constellation is this? This is in Canis Venatici. So, yeah, see, in fact, there it is right there. So it's right between the two primary stars of Canis Venatici. So it's, in fact, it's almost centered between the stars. Right there is where it is.
Okay, the Croc's Eye Galaxy, or M94. Let's go to our next one here.
going to be M106. There you are up there. Center you up a little bit. Alright, this one's going to be M106. ZWO 106. It's an intermediate spiral galaxy in Canis Venatici. It was discovered by Pierre Marchand in 1781. It's 22 to 25 million light years away, so again, one of the closer ones, like the Pinwheel and the Whirlpool galaxies that we started off with. This one's somewhere in the 20 to 25 million light year range away. There we are. Look at all the other galaxies that are in the image. Look at all the rest of them in there. We got a nice one here that has a nice edge on spiral. And we got a few to look at here. This one's actually pretty nice. It's got a nice dark dust lane coming right through it here. We'll look at it more closely once we get some more subs in here. But M106 is the star of the show. This one up here. Put this up there. So yeah, this M106 is the big one. It's classified as a Type 2 Seyfert galaxy, and the presence of a central a central supermassive black hole has been demonstrated from radio wavelength observations. It has a water vapor megamaser, the equivalent of a laser operating in microwave instead of light. So it's a maser, a megamaser, and on a galactic scale, a water vapor megamaser. Water masers are useful for observing nuclear accretion disks in active galaxies. The water masers in M106 enable the first case of a direct measurement of the distance to a galaxy. They are providing an independent anchor for the cosmic distance ladder. Okay. It's one of the largest and brightest nearby galaxies, similar in size and luminosity to the Andromeda. And supermassive black hole at its core has a mass of 4 times 10 to the 7th million solar masses. Definitely a whole bunch of galaxies in here. One there, got one there, got, looks like 2 there. These look like stars. Certainly one there, certainly one there. Certainly one there. In fact, we can get our plate solved directly on and then see how many there actually are. Now that's how many there actually are in this view. Lots and lots of them. So according to the Wikipedia article, this one, 4217, this nice edge-on spiral galaxy with the dust lane in it, is a satellite of 106. So they're kind of orbiting each other. But yeah, a mess of galaxies, most of them small and faint, but a whole mess of galaxies in here. A whole mess of them. They look like stars, but they're not. So we can zoom in on 106 a little bit. We can definitely see some spiral structure in there, even some spiral structure on this. The arms swooping out and around. Swooping around with it. It almost looks a bit like M94 with two kind of sections of sort of this brighter intersection and then the much more faint, wispy outer section. Almost like two ring systems again. But I think they're all pretty much kind of integrated. Maybe this one actually is all connected to this. And then this one kind of does that. See if we got enough yet to look at that little guy down here. Yeah, fortunately he's kind of partially clipped, but yeah, you can see a nicely defined dust lane down here. We catch it almost directly edge on, with a nice central bulge in there, and a nice dark dust lane cutting right through the middle. That's a sweet looking galaxy. It's NGC 4217 for those keeping score at home. That's the name of this one. It's a nice galaxy. I think we might have even looked at this one 2 weeks ago when I did what I did last time. I think we did these last time. That's a sweet little galaxy there. Dropped a sub. We dropped a sub exposure. Yep, looks like we might have gotten a little wisp of cloud. Might have drifted in front of our galaxy there. We dropped that last sub. Let's see what this one does. Yeah, that one came in just fine. So, might have just had a little cloud moved in front for that one sub exposure. Yeah, that one was back to being fine again. So just temporary little blip there. Let's try balancing the colors again. I haven't done that in a while. Makes it just a little too blue, but I also have to watch to make sure can't cross that line. Careful of those. Whoa. Oh. And something just... That's odd. Why are those all streaked? Oh, the guiding has just gone completely nutty. That's why. Guiding has gone completely nutty. Well, let's just move on to the next one. Let's move on to the silver needle. This one has been ruined by the guiding. It lost the guiding. So I think we saw most of what we could see from there anyway. This one's very close to the meridian. We're not going to get a lot of time on this, but we'll get what we can. Silver Needle Galaxy. This is a pretty nice one. Silver needle. What is it going to be? 4244. So we can see about the silver needle. Let's see, 42. It's an edge-on loose spiral galaxy. The constellation Canis Venatici is part of the M94 group, which is a galaxy group relatively close to our local group. It's approximately 14 million light years away. Oh, so it's a relatively close one. It's only 14 million light years away. So yeah, this is one of our closer companions. To watch this because we can't cross that line there without doing a meridian flip on the mount, so need to watch that. I don't think we'll do a whole lot with this one, but we'll get a few subs. Let's see what we're going to go to next. Well, we've done that one. We've done that one, I think. Did we do this one? 4182. Yeah, this was a really dim one. 41. I see 4182. That was a really dim one that we had to pass on there. So Let's see. Alright, let's see what we got here next. Pup Galaxy. Pup Galaxy? Not sure why that's showing up. It's too small. Koi fish. Yeah, that one's a pretty good one. We'll do the koi fish next. Definitely silver needle looking. Don't know if we're going to be able to see any detail in it. So, 14 million light years away, it is one of our more local guys. So let's head over and see the koi fish. Okay, center that up. Get it started. Sync that up. Definitely an interesting looking one. I think I'm gonna delete that first sub as the guiding was a bit wonky on that first one. So I think we'll start this one over here. Clear that first one. Let a new one come in. Star should be a lot rounder. Yeah, there we go. That's a lot better. So this is 4559. The Koi Fish Galaxy.
Okay, let's see what we can see about this koi fish galaxy. NGC 4559 is an intermediate spiral galaxy with a weak inner ring structure in the constellation Coma Berenices. Distance estimates range from about 28 million to 31 million, so somewhere in the 29 to 30 million light year range. So again, a little bit further away. So about 30 million light years for this one. So a little bit further away. So anyway, not a lot of information from Wikipedia about this, but it is a spiral galaxy, and you can kind of see that. Got a core here, possibly even a barred spiral, a little bit of a bar there, and then the spiral arms kind of swirling out from the center like that. So we're seeing it not edge on, not face on, sort of. I think closer to edge on than face on, so we're seeing mostly an edge, but you can see just enough of the face to see the swirls of the spiral structure that are in here. But at 30 million light years, it's a good distance away, so it's not a real big one in our skies. How close are we getting to the meridian there? Oh, not too far. I may actually have to flip over at some point. Well, I think I may be able to hang on for tonight. Stay on the east side tonight. We'll just do 10 minutes on this and move on. Interesting little structure of a interesting little spiral galaxy. But I think at 10 minutes we're good enough. Let's see where we're going to go to next, huh? Let's see what that one looks like. It's an active galaxy. Well, let's see what that active galaxy looks like. Next target. Go. Pulls me a little bit further. It's probably not going to be a very strong one. Let's see. It should be somewhat of a decent size. We'll see what how bright it is. It might be pretty faint. We'll just have to see. That's a pretty nice looking one. Lots of interesting stuff going on there. 4725. With friends, of course, including some pretty nice stars here too, nice yellow stars. So let's see. 4725. What we can get from this one. 4725. Twink. Come on. An intermediate barred spiral galaxy. Yeah, you can see the bar right there. Clearly a bar in its central portion. Prominent ring structure located in the northern constellation of Coma Berenices near the northern galactic pole. Discovered by William Herschel in 1785. The galaxy lies at a distance of approximately 40 mega light years. 40 million light years away. So again, we're going significantly further out. It's the brightest member of the Coma 1 group, although it's relatively isolated from the other members of this group. This galaxy is strongly disturbed and is interacting with neighboring spiral galaxy NGC 4747 with its spiral arms showing indications of warping. So NGC 4747 4712, so it's saying it's interacting with this guy up here. Not this one down here, but this guy up here, as they're saying, they think it's a suspected Type 2 Seyfert galaxy with a supermassive black hole at its core.
classification indicates it is a peculiar weakly barred spiral with a complete ring surrounding the bar and somewhat tightly wound spiral arms. It is actually double barred with a feature found among about a third of all barred spirals. The galactic plane is inclined at approximately 46 degrees to the line of sight from Earth. The ring structure is a region of star formation, is offset from the galactic center, and displays non-circular motion. So according to them, these two are separated by about 370,000 light years. So they're very close together, actually, even though they look pretty far apart here. They're actually pretty close together. Which actually seems really odd, 40 million light years away. Warped NGC 4725 out of shape. It's a pretty interesting looking galaxy, though. Definitely some cool spiral shape to it. There's actually some structure in this one too. That's neat. Give this a few more minutes, see what more detail we can pull in, let it smooth out. guy here has got definitely a little spiral here too. This one's kind of a cool little guy. This is a star, probably in the foreground from a Milky Way star, but that's the core, and obviously a nice little spiral of its own. But yeah, nice little galaxy here. Finish the night with another Messier object, another black eye galaxy, M64. This guy up with a full 15 minutes. Give it the full 15 minutes. There we go. Now we'll go to M64 as our last target for the night. Black Eye Galaxy. There it is right there. We don't even need to redo it because it's already centered up nicely. Sub because the guiding took a minute to calm down. So I'm going to nuke that first sub. Get a little bit tighter around her in better detail. But this is the Black Eye Galaxy as we see this right here. This inner ring will turn darker once we get some more subs in. Maybe we'll see that black eye. Alrighty, so this is M64, Black Eye Galaxy. Let's see what we can see about this one. 64, the Black Eye Galaxy. It's a relatively isolated spiral galaxy 17 million light years away from the in Coma Berenices. It was discovered by Edward Pigott in March of 1779, independently by John Earl Bode in April of the same year, as well as by Charles Messier the next year. A dark band of absorbing dust partially in front of its bright nucleus gave rise to its name of the Black Eye, or Evil Eye, or Sleeping Beauty Galaxy. M64 is well known among amateur astronomers due to its form in small telescopes and visibility across inhabited latitudes. Morphological classification indicates an outer ring-like structure, a non-barred spiral, and fairly tightly wound. It's a Type 2 Seyfert. The central region is a weak source of radio emission. A soft X-ray source has been detected at the nucleus. Has approximately 100 billion stars in the galaxy. Yeah, that's about all that's interesting. But anyway, it's a fairly close one, only 17 million light years away. So just a little bit closer than the whirlpool and pinwheel that we started off with this evening, which were about 20 to 25 million each. Yeah, you can see sort of a dark band here. So bright, I'm going to back off on the stretch a little bit to pick up some more detail. It's a very bright galaxy, which is why it's so good for amateur astronomers. It's not very big, it's not tiny either, but it's really bright. It's got a lot of surface brightness. So this is, I'm sure we're going to get a lot more detail out of this. It's so bright I keep having to back the stretch off a little bit to see more of the inner stuff. Which means we lose a little of the outer size, but get a little more of the stuff going on in the middle. It's a very bright galaxy. The stretch, you see more of the outside, but then the inner part gets blown out, so it actually just looks better to have it here. Just looks better to have it here because that just gives us a lot more detail in here. But still don't pick up a whole lot from it. We have to spend more time on it. But in any event, I think that's going to about wrap it up for me tonight. So, thank you for watching. I appreciate you being here, if you were here, and if you're just watching after the fact, well, I still appreciate you being here. So, thanks for watching. Hit the subscribe button if you feel like it, or give me a thumbs up or something. And yeah, thanks for watching. I hope you learned something and enjoyed what it is you were seeing. I know I enjoy doing this stuff and showing off some of the beauty in the sky, so thanks for being here and appreciating it with me. So, in the event, I will see you guys next time, and adios.